Hello everyone, welcome back to our chemistry class. So we are still in 4.4 Intermolecular Forces part B. So in this video, we'll be talking about hydrogen bonding, factors affecting hydrogen bond, and effects of hydrogen bond on the physical properties. So hydrogen bond is a strong permanent dipole-dipole attraction between the positively charged hydrogen atom of a molecule and the negatively charged small and highly electronegative atom such as F, O, and N atom of another molecule. So as you can see from the diagram, the hydrogen bond is formed between the negatively charged fluorine atom with the positively charged hydrogen atom that is attached to a molecule. So there are two requirements for hydrogen bonding. First molecule has hydrogen attached to a highly electronegative atom N or F. So dalam erti kata lain, hydrogen itu akan attach dengan F, ataupun hydrogen itu akan attach dengan O, ataupun hydrogen itu akan attach dengan N. Yang mana hydrogen ini dia adalah positively charged sebab dia partially positive. And then the second molecule has a lone pair of electrons on a small highly electronegative atom N or F. So the second molecule adalah juga daripada FON, yang mana FON ini ada lone pair. So sebagai contohnya kita ada molekul amonia di situ. So N, nitrogen, is a small highly electronegative atom that contains lone pair. Therefore, untuk form hydrogen bond, lone pair ini dia akan connecting dengan hydrogen yang attach sama ada dengan F atau dengan O atau dengan N. So dalam case ini, lone pair pada nitrogen itu dia akan attach pada H yang attach pada O. So itu adalah apa yang kita panggil sebagai hydrogen bond. So macam mana kita mau tentukan hydrogen bond hadir atau tidak? So kita kena tengok lone pair pada F, O dan N. Lone pair itu dia akan attach dengan H, hydrogen bond yang attach pada F, O dan N. So dalam contoh yang saya tunjukkan ini, yang saya highlightkan berwarna hijau itu adalah apa yang dimaksudkan sebagai hydrogen bond. Next, kita tengok factors affecting hydrogen bond. So there are two factors affecting hydrogen bond. The first one is polarity, and then the second one is extensiveness. So for polarity, the more highly electronegative the atom, the stronger the hydrogen bond. Therefore, the strength of hydrogen bond in HF is greater than NH3 because fluorine is more electronegative than nitrogen. Itu sebabnya boiling point and melting point of HF is higher than NH3. The second factor is extensiveness. So, the more hydrogen bond per molecule, the more energy needed to overcome it. So water can form 4 hydrogen bond per molecule, while HF can only form 2 hydrogen bond per molecule. Therefore, the boiling point and melting point of water is higher than HF. So maksudnya begini, kita ada satu molekul air dan kita ada satu molekul HF. So molekul air ini dia akan dapat bentuk 4 hydrogen bond. Macam mana? So kita tengok yang saya highlight berwarna hijau itu. So hujung dan hujung pada highlight itu dia boleh form hydrogen bond. So di sana sudah ada 2. And then bila saya highlightkan berwarna biru, hujung dan hujung warna biru itu pun akan dapat menghasilkan hydrogen bond. So total of hydrogen bond per water molecule is 4. Tapi untuk HF, dia cuma boleh form 2 hydrogen bond per molecule. Itu sebabnya boiling point and melting point of water is higher than HF. Next, let's take a look at effects of hydrogen bond on physical properties. So dia akan beri 3 kesan. Yang pertama daripada segi boiling point, kedua solubility, dan ketiga density. Untuk effects of hydrogen bond on boiling points, kita akan tengok daripada group 14 until group 17. So when we look at the trend of boiling points of hydrides in group 14, we can see that the trend displays a normal behavior of boiling points. So the type of intermolecular forces exist between the molecules are van der Waals forces. Okay, this will cause the boiling point increases regularly, and the factor that cause this is the relative molecular mass is increasing, and it will cause the van der Waals forces also increasing as the molecular size increases. Next, let's take a look at trend of boiling point for hydrides in group 15, 16 and 17 except for ammonia, water and HF. So as we can see, down the group, the boiling points will increase. So the increase in boiling point is due to the increase of van der Waals forces as the molecular size increases. Hydrogen bonds are not present in this molecule. Next, let's take a look at the boiling point of ammonia, water and HF. So as we can see there, the boiling point of ammonia, water and HF are strangely high compared to the other hydrides of other elements in the group, sebab kehadiran hydrogen bond lah. So the boiling point increase in such order. Ammonia will have the lowest boiling point and water will have the highest boiling point. The strength of hydrogen bonding is proportional to the polarity of the bond. Okay, even though fluorine is more electron negative than oxygen, water has higher boiling point than HF. Ni sebabnya water tu dia boleh form 4 hydrogen bond per molecule, tapi HF only form 2 hydrogen bond per molecule. And finally, HF has higher boiling point than ammonia because of stronger hydrogen bonding of HF. Okay, next let's take a look at effects of hydrogen bond on solubility. So we all know that water is a good solvent for liquids and gases that consist of small polar molecules, sebab dia boleh form hydrogen bond dengan water molecules. Sebagai contohnya, ammonia is soluble in water because ammonia molecules can form hydrogen bond with water molecules. Selain daripada itu, alcohols and carboxylic acid also are soluble in water because the OH groups in the compounds can form hydrogen bond with the water molecule. Tapi bukan semua organic compound yang mengandungi NH2 ataupun OH will soluble in water. This is because as the relative molecular mass increases, the non-polar hydrocarbon portion becomes larger. So ceritanya begini, NH2 dan juga OH ini dia akan soluble in water sebab dia adalah hydrophilic area. Tapi dia ada ekor yang kita panggil sebagai non-polar hydrocarbon portion. So ekor ini adalah kita panggil sebagai hydrophobic area. So hydrophobic area dia benci air, hydrophilic area dia cinta air. So as the hydrophobic area becomes larger, okay, the solubility of the molecule will be decreasing. Ini juga kita akan bincangkan dengan lebih mendalam semasa di semester 2 nanti. Lastly, let's take a look on the effects of hydrogen bond to the density of water and ice. So we know that water is unusual in its ability to form extensive hydrogen bonding network. So when the water is cooled to solid, okay, it will arrange themselves to form a tetrahedral arrangement in such a way to maximize the amount of hydrogen bonding between them. then it will leave a relatively large amount of space between them and gives rise to an open structure. So this arrangement of molecules has greater volume, tapi dia kurang tumpat berbanding dengan liquid water, sebab water will expand when it's frozen. So the three-dimensional structure of the covalent bonds and the hydrogen bond is shown in this diagram. So bila kamu tengok di sana, okay, water molecule tu dia susun dirinya sendiri dalam bentuk tetrahedral arrangement bila dia disejukkan. Okay, and this will give apa yang kita panggil sebagai open structure dan menyebabkan air akan mengembang apabila dia disejukkan. This slide show the 3D structure of ice. So if you look closely, that is what we call as the open structure in the ice. The open structure of the ice accounts for the fact that it is less dense than water at 0 degrees Celsius. But when the ice is melts, some of the hydrogen bond will be broken. Okay, this allows the water to be more compactly arranged, resulting in 9% decrease in volume. Therefore, water has a higher density than ice. So itu sahaja untuk video kali ini. So kita sudah habis 4.4 intermolecular forces. So kita akan sambung dalam video yang seterusnya, 4.5 metallic bonding. I'll see you in the next video. Take care and bye-bye.